right, hi everybody and welcome. We're going to be hearing from Marcos today about rethinking line of business applications, Graphs and Cypher as an alternative to RDBMS and SQL. So I'm going to go ahead and hand it over to you, Marcos.
Okay, thank you very much. Okay, hello, Notes 2025. I'm excited to be here today. I want to thank Neo4j for the opportunity to present, some of my ideas and concepts. Okay, look, I've been in the industry for over 40 years, 17 of them at Microsoft. Okay, I've been working with platforms, software development, and databases most of my entire life. Okay, most of them are SQL or tabular databases, and in the past 10 years, or a little bit over that, I got to know graphs, and that kind of changed my mind. So over the last 10 years, I guess, or more, right, I've been exploring, how to use graphs, in a way very different from the traditional analytics that we are used to, but instead of running business applications on it. That is, using graphs as a transactional data layer instead of relational databases or any other tabular database. So today I'll share some of my learnings, right, and concepts that I've developed. I'll also share, this what I call a graph native mindset, right? I'll start walking you through some concepts and ideas, right? And then we'll see them in practice in a demo, right? It's a lot of content to dig in, right? I'll share this later on another post so you can actually read it. I hope this challenges some of your assumptions, right, and sparks new ways of thinking. That's the whole idea here. And my intention here actually is just to point direction, right? So let's go for it. So, whoops, there you go. So graphs, well, I don't need to talk too much about what they are, right? There's critical, data layer. They have become, a critical data layer for analytics, right? They've done amazing things, for extracting knowledge from both structured and unstructured data. They have powering systems like fraud detection, recommendation engines, logistics, and so forth, right? And recently with AI, right? GraphRag again, graphs have been a main platform or database, right, for creating reducing hallucination and improving factual accuracy. So it's clear, right, that for the future intelligence systems, data and knowledge can no longer live apart, right? They have to go together. So the only issue is that today all these graphs, they depend on the structured data, right, that a large amount of systems, right, inside the enterprises use, right? That's siloed in different applications. And for graphs to actually use that data, they have to go through data pipelines, right, and transform that data so they can actually be used and that the knowledge can be extracted. And so the issue there is that what you see on a graph is actually a snapshot, okay, of how the process was, okay, or the business state was at the point of extraction. It's not in real time. Now, data lakes have shortened or reduced that gap, right, and has helped us a lot because now data can be stored, in the same repository of the analytics data, right? So that helps. Nevertheless, okay, they are still treated separately. Okay, so we have the data that runs on processes, right, or run the business, and the data that runs analytics. It's done in different times, different moments. So to get over that, right, the idea here is to have everything in one place, right? Data and knowledge have to be conceived, together, right, at the moment of inception, right, when they're created. So we do that, right, by putting everything on a graph, right? That's what I've been doing. There's no way to do that on tables, right? You have to create knowledge and data together. So that's why we move to this, what I call, this graph native systems, right, or mindset that I'm creating. So build everything from ground up, on a graph, right, as a primary data model. And to do so, right, the graph, it then becomes a dynamic graph, okay, application graph, rather than the static knowledge graph that you might be familiar with, right? So it's a slightly different type of graph, right? So in this presentation, I will explore this new approach, okay, for designing and developing graph-native business applications by unifying data and knowledge from inception. So let's go there. So if you migrate all the knowledge, I mean, all the information or the way that you work, right, to the graph, if you're familiar with working with traditional relational databases and you port that to the graph, it's not going to work, right? You cannot migrate, the way of thinking that you do on relational to the graph. It's not built for that, right? You actually will create more problems. Yeah, we can think in terms of tables and data and expect to derive graph and knowledge. To succeed, okay, we must unlearn decades of relational, thinking that happened to me, right, and relearn, new models, new querying, new way of querying, and reasoning, and unifying data and knowledge in an entire different way. Now, this isn't just a shift of technology; it's actually a shift in mindset, right? So for us to understand the current mindset, okay, we have to go back a bit and see where did it all started, right? So why are we using tables in the first place, right? So it all started like 80 years ago, right? When the first computer was created, like the ENIAC, right, was the first digital computer. We were solving table problems, right? We had a table of parameters, right? We were doing artillery firing tables. That was the purpose that the ENIAC was created, right? So we had a table of parameters, right? And we had to scan through them sequentially, right? Doing iterations, mathematical iterations, and then create another table, right, with the results. So that shaped, the whole computing model that we're using today. Okay, it was built for calculations, on a table space, right? Everything derived from there. Now it's an amazing computing model. It's done for its purpose, right? It's fantastic. I mean, it landed a man on the moon, right, and brought him back safely to Earth. I mean, that's amazing, right? And it's so efficient, so brilliantly, suited for its purpose that we never really imagined that we might one day need an alternative one, right? So despite decades of abstraction, we still design systems that are kind of table based, for that specific model. And this brings us to this interesting question. So what if, right, our first problems had not been mathematical table based problem, but they had been, let's say, interactive network, right? Different kind of problems. Had we invented a new computing paradigm? Maybe, right? So we fast forward 80 years, and what's happening today? About 70 to 80%, right, of our business problems, right, or applications that we have are not tabular, are interactive networked, like the image here, right? When we have knowledge coming in and data, then we have to kind of reason, decide, and then move to the next steps. They're all workflows, right? Like I said, 70 to 80% of our problems are workflows. But nevertheless, we're still using that old paradigm that wasn't built for this. We're using calculations. Yeah. So that creates a big, problem to us, right? And we need to change, the mindset, right? We're using an 80-year-old model. It works though, right? Perfectly well. I mean, we've been using it, right? In the same way that you can chop a tree with an axe, right? But as the trees grow bigger, right, and numerous, having bigger and more axes and stronger axes is not going to do the work, right? At some point, we need to create a chainsaw, right? And our axe skills might not work anymore. Yeah, so a significant portion of these applications, that we have today can run on a different computing paradigm, right? And there's a part that still can run on the previous model. So let's take a look, right, of what we need, to do that. So we need to change from that traditional, relational mindset that we had, right, and change the concepts. Like we look at in table in relational algebra, right? We use set operators, like union, intersection, difference, and the Cartesian product. Yeah, when we switch to a graph model, we need to change those set operators, right? We're going to use superset, subset, an element of, right, to explain things. We go from an implicit, right, representation, because those are very implicit operators, to very explicit ones, right? So that transforms a lot in the way that we communicate and we see the information, and that's how knowledge starts coming up. So when we go to a set, okay, mindset, okay, to defining the whole world around us, right? We adopt this set-oriented mindset. We start working with collections, right? So some nodes in our graph will represent collections, okay? They group together information, and that brings a new way of changing the way that we do things. We normalize, okay, everything in those one-to-many relationships that we used to normalize in tables, right? We use it in sets, right? And we become more explicit, okay, by containment, you know, and membership. We start expressing context in the graph. So the purpose, okay, of using, you know, a node as collection is to align, you know, the graph structure with the mental model of the domain owners, because we tend to do everything in sets, right? Today, even our, you know, homes, you have rooms and cabinets and closets, okay, to, you know, your business, you organize everything in sets. So that's the way that we start organizing things here, and we'll see that the way that we do that on a graph, right? So if we start looking at comparing how we do that on an ER model, right, and we move it to the new set mindset, right, it becomes quite evident, right? And first thing that you start seeing is that we start removing some, you know, hidden entities, hidden properties that we had inside our entities, right? They start showing up as relationships, right? So if you see here in this slide, you see a product, right, has an SKU and then has a category. What used to be shown as a primary and foreign key before, right? It becomes a relation, right? So you start creating that relationship that now, like I said, is a very explicit. So relationships themselves, they carry the meaning, okay, and express, you know, in an explicit way, right? While the entity only holds the essential, you know, information that identifies that specific node. When we expand the model, right, and that becomes even more evident. So now you can start seeing how a node becomes a set, okay, when you have a hierarchy, right? And the nodes, like when we strip all the entities, all the properties, right, that used to describe this foreign context, right, to them. Do you have any question here? What happens is that it becomes quite explicit, right? And the result, you know, is a structure that it mirrors, you know, the real world, because that's the way we organize things. Right? It makes data, you know, more meaningful and self-evident to both, you know, all domain or the domain experts, okay, both from the problem who understand the business, right? I call them the problem domain owners, and the developers, okay, which are, you know, they understand the solution. And in the same way, our AI systems are able to read this very naturally, right? So everything is done explicit rather than implicit, hidden inside the nodes, right? And another thing that happens, right, is that by stripping all the properties from the node, right, that are referred to their context and things like that, the nodes become like proper nouns, right, inside the graph, right? So each node has its own identity individually. Another thing that happens, right, when we move to sets is that the relationships, okay, they start also representing state, okay? So when you have some properties on a specific entity that represent a state, okay, we're probably familiar to changing that property, right? And that property now, it's part of a graph, right? We use sets, okay, to put it. For instance, here we have a store that might have one collection, okay, we'll call inventory, and another collection called, you know, sold products. yeah, and a specific product cannot be in both at the same time. Okay, it's either in stock, right, in the inventory, or it's a sold product, right? So at that point, the relationships, okay, they start representing state, and the graph now becomes a state machine, which means that from now onward, right, we represent state by changing relationships, okay, in the graph, rather than by changing property values on the specific nodes. Okay, that's a massive change, right, in the way that we operate today. Okay, and that might be, okay, very different for the way that you operate. Now, interestingly, right, at the moment that we start doing that, right, and our graph starts representing like a living business model, right, we can go and tap into nature, right, for inspiration and some validation, because that's the way that nature works, right? If you stop and think, right, everything that we have today, right, it's about 118 very normalized elements, right, that they don't change. Okay, all they do is just switch, right, the relationships. Okay, that's how everything that you know works, right? We can do the same, right, with our business, right? If I have a very normalized entity, we don't need to change the content of that entity again, right? Which means that's a massive change in the way that you're probably familiar working, right? So when we move to this graph native mindset, right, what I'm proposing here is that actually we don't change the properties of an entity, right, but rather we only change the relationships. If it's well normalized, that should be possible. Okay, that's a very important concept, okay, for this. Now, I understand that this might be quite unsettling for many of you, right, that has probably spent your entire life building applications where all you have to do is just change the property values of your entities. When we move to graphs, right, for this new approach, we don't do that anymore. Okay, we just change the relationships, and that does the work, just as in nature. That's the way that nature works, and we'll do it here, right? So, but to be fair, okay, nature does allow, okay, a way for you to change a few properties, okay, and in nature we see that as isotopes, right? If you see isotopes, you can actually change a few things as long as you don't change the essence, okay, of the element, right? You can actually do that. So hopefully that, okay, brings some comfort for some of you, right? But again, we can only do that as long as we don't change, you know, like I said, some very the entity state, you know, the contextual relevance, you know, and the meaning of the content. It could be things that are not so impactful in the whole model, right? And that has to be done very deliberately and very wisely, right? Otherwise, you know, the whole model can get a bit radioactive, right? So when we do, oops, sorry, here. So when, oops, change a bit things here. Okay. So when we move to that model, right, we can look at, you know, a good example would be photosynthesis, right? Photosynthesis that does exactly that, right? If you look at the way it works, the same 36 elements that come in, right, come out of the process, right? And anything that all that changes is just the relationship. Okay, nothing else than relationships changes. Okay, so that's the elegance of nature that we can also use when building solutions on a graph, right? So your ultimate business modeling goal here, right, is to design a graph that can be fully understood, okay, at any state, any moment, right? Just simply by reading, you know, the node labels, right, and the edge types. That you don't have to go and read any property, right, of any node, and you can actually tell what's going on, right? If you achieve that, okay, that's perfect, right? I mean, if there's anything that I want you to remember from the entire presentation is that, okay, that try to create a model, okay, where everything is represented and you can actually understand it just by reading the node labels and the edge types. Right? So this changes everything, right? So if we go for that, it works pretty well. And I can say that, look, if I've been testing several graph databases and applying this model to it. And Neo4j, it does it pretty well. I mean, because of it's the schema-less, and strong, consistent foundation that Neo4j has, it works quite well, right? Some other graphs that are schema first, okay, you will struggle a bit. And another thing that works quite well, it's that besides Neo4j not being fully optimized for this, because nobody uses it in this way, right? It works quite well, so it can only get better. That's what I can say here. So another interesting thing, right, that once we start, stripping out all the properties, right, and normalizing, right, our entities, they start assuming like kind of molecular structure, right, for every business object, right. It probably depends on more things like we have here. Okay, a customer, you can have a wallet, right, and it has payment methods, right. You can have a billing address or different addresses, that an address book, right. If it's a shopping cart, it has a shopping cart and all the products over there. So they create a molecular structure. So ideally, right, when you start creating this business objects, they all have the same molecular structure, right, as to represent them. So that's an important thing. And in an ideal scenario, right, when you create your models, right, you create these entities, right, in a way that they can be, used across all your enterprise systems without any change, right? Which means that if you have other systems, okay, that use the same element, right, or the same entity, right, that entity doesn't have to be replicated. You don't create copy. All you have to do is just connect it to different systems. Okay, that creates, a unified across federated graphs. Okay, now that Neo4j has, an infinite graph, right? You can have several systems running and using the same entity without having to replicate it. So I think the best way to actually see this working, right? It's an application. That's what I did here. So I created a small, proof of concept. One application that everyone is familiar, which is a ride hailing. And I'm going to show you how this concept, okay, of having entities that don't change, right, but only everything is done just by connecting and disconnecting nodes, right, and run the whole process, right. So I'm going to show you that in this application. This was an application built in TypeScript using React, right. It's running on an Azure, okay, instance, and it's accessing a Neo4j Aura database, right. So let's go for this application. I called it Elder Write, right? And I'll switch to the application. Can you see it? Yes. Okay, so what you see here, I have on my left side here, one instance of the application running. This is the front end, the client side of the application. I have two instances of it. Okay, I'm going to use one as my passenger, right? And I'm going to call list of passengers here. And then I'm going to use the right side as my drivers, right? So I have a few passengers in the system, a few drivers. I'm going to get Peter as my passenger. Let's get Albert here as my driver. So what you're seeing here is the UI that they have. And before I do that, here on my right side, I have the Neo4j console, so we can take a look at what's going on. So let's go and call here. This is the passenger, so you can see Peter. Okay, I'm gonna grow this one here. So this is Peter's, like I said, the molecular structure of Peter. Okay, so this is him, right? He has a wallet, so he has more payment methods here that he can have. He has a preferred payment method. He has an address book. Maybe he can have the most used addresses over here. This is history. Well, he probably connect all his past bookings. Okay, they're all here. And this is the collection that he belongs. So this is the passenger collection, right? And all the passengers are there. Okay, so you see the direction over here, right? It's from the collection, right? From this superset, right, to Peter. If we expand that one, you can see all the other passengers in the system, right? So cool. So now let's go and take a look at our driver. So I'll call the driver here. And just like we had from the passenger, right? What you see here, it's the driver. This is his molecular structure. So just as the passenger, he has a wallet, right? That's the way that he's going to be paid, right? He has a history, past booking that he's done, right? He has a car, and the car is also pointed to him. And you can see the car here, right? The car is on the available, it's part of this collection. So he's in that set, okay? The available set means that the car is available at the moment, right? And these are the superset fleets, okay? And you have other sets, okay, around it. So what we're gonna do, depending on where we are in the system, we're gonna connect it, okay, based on the status that they are. So let's go here, okay? And I'll keep this one open. And I'll go with the passenger. I'm going to pick an address. Okay, these are coming from another collection that I have. Okay, with all the addresses, I'm going to got a pickup location. I'm going to get the destination, and then I'm going to go and book. Okay, I got a pricing, and you see here on the driver app. Okay, you can see already here. So we're going to refresh this here, and you see that now Peter has a booking. So now he has a booking. We can expand that booking, and you can see this is the molecular structure of the booking, right? It has an origin address, right? It has a destination, it has a payment method, right? And you see it's part of the weighting. So this is the state, okay, that booking is. I'm gonna do this. I'm gonna open this one here. I'm gonna get that booking number that's generated by the system. I'm gonna copy it, and I'm gonna call another query here. I'm gonna get the booking query. I'm gonna change that one so we can see it. Oops, I did something wrong here. Did I got the right one here? Okay, it has not been picked up yet. So, okay, let's do here. Sorry for that. So what I'll do this, I'm gonna get this guy now, I'm gonna pick it up. Okay, I'm gonna refresh this query. Get this one here. Okay, you can see that now that booking has an active car, right? Has been picked up. So probably this query now will work. Okay, so sorry, this one here. Okay, so now we're seeing the one that I wanted to pull. So you can see here the full booking schema, right? So you have the booking over here. You see it's active. You see the car, but it's now busy. If you remember before, it was available. Now the car is busy. Here's the passenger, and you can see that how they all connect here, right? What I'm going to do now, I'm going to be the driver, and I'm going to pick the passenger. So for now, I just accept it, right? The right, but I haven't picked up the passenger yet. So I'm going to pick it up. I'm going to refresh this query. And you see that now I have another collection. Okay, now we have picked up. If you look at that picked up, you have the timestamp, so I can actually trace it and have an audit trail, okay, on the booking. The booking goes on. Okay, Peter is going to take Albert to his destination. At the end of the ride, he's just going to drop it. Okay, and I'm going to refresh this query again. And now you see that the booking is not longer active. It's now part of the past, right? The car is now available again over here. Right? It's part of the available cars. Oops. Can't scroll here. Here's the passenger. Now they have the history, right? The booking is now part of the history. So now let's take a look at what happened. Okay, let's go out of here. Let's go back to the presentation. And let's examine what's happened on the background. There you go. Oops, sorry for that. There you go. Okay. So the first thing I did on the application, right, was to define a pricing. So I have one little query here that simulates a dynamic pricing. Okay, it's going to divide, the booking weighting by the cars available. So you can actually, if you run this application, you have too many cars, you have fewer cars, okay, available, and you have too many booking, the price is going to go up. Now, on the real world, okay, this is going to be done, okay, not on the graph on this model is going to be done probably by a microservice running that old, ENIAC computing model, right, where it's built for calculation. Okay, once you do that, right, I get the pricing, and then I execute only one ACID query here, right, which I create the whole structure, right, for the booking. And you can see I put it on the waiting list, right? I connect it to the to the payment method. Okay, I connect it to the booking, the passenger pickup, okay, the drop off, and I put it on the waiting, on the waiting list, right? Next, what happens is the drivers, right? They're going to query the booking, the waiting list. So they go for that waiting collection, right? To see all the bookings that are there waiting, and he's going to pick one. Okay, they can fetch all the information that you need, right, from this, and then the driver selects a booking. So what happens here? It's very interesting because the first driver, okay, that disconnects the booking from the waiting collections, right? It secures the booking for them, right? So that's the multi-user, okay? When whoever does that first, okay, that's where ACID plays a big role here, right? And that one disconnection, okay, drives the whole thing, right? Nobody else can actually book the same booking or pick the same booking, okay, once the first one is done. So when you do that, okay, you connect it, you delete, the connection from the waiting, you connect it to the available, right, and so forth. Next, what we do here, okay, the driver, when you pick it up, right, you create that picked up location connection, okay, relationship between the booking and the car, so we can have it and add the timestamp. Lastly, okay, when we drop the passenger, again, everything is done through just connecting and disconnecting. We have no change whatsoever, so we don't use the set command at all, okay, the entire transaction. This might be quite different for the way that you're familiar, right? And everything is done, so we actually, we connect, the booking to the history of both the passenger and the driver, right? We connect the booking to the pass, so the administrator can go directly, okay, and to the past collection and fetch all the past bookings. We put the car in the available collection. Okay, we remove the has active, booking from both the passenger and the car, right? So we kind of unsettle everything and we leave it in the state and then the final state. If you look at the graph, okay, and this is the way it is. It's interesting that you can actually, like I said before, you can actually read, okay, what's going on here, right? You can look at this, you can take some time to read this. Just by looking at the labels, okay, and the edge types, you can tell exactly what's going on here. You see that a passenger already booked a car, right? That the car has not picked up the passenger yet. It has only two relationships here, not they picked up, right? And you can see what state they are, active, whatever, right? And the good thing is that this is a common language, okay, between the business domain owners, right, who understand the problem, like I say, and the developer team who understands the solution, and AI. So your AI systems can read this in the same way that you can, right? It's built for them. We have a unified language, okay, across all the domains and AI. So moving ahead, how much time I have? Okay, I have to run here. So key points here, okay? Nodes are proper nouns, right? So these are design goals. Remember, create nodes, okay, and entities, okay, that only have whatever identifies them, right? Keep the loads quite lean as possible, right? Less relationship. Don't create super nodes, right? There's a lot to say about this here. I don't have time. Read-only nodes, right? You don't change, okay, the properties. They're read-only. You don't delete nodes also in this model, okay? You keep everything so you can trace everything back. And the relationships, they drive the whole system workflow. So these are the key design goals that we should try to follow. So going to the conclusion, we still have some time here, okay? So like I said, this is much more than just switching a technology, okay, from relational databases and SQL to Graph and Cypher, right? This is actually a complete new paradigm, a complete mindset change, right? What I want to say here, that graphs are not only analytical tools, they can actually be, and they must be used for transactional databases, right? They have the potential, okay, to transform the world, okay, by doing that, by having knowledge and data and logic, okay, all in one place. You will have to unlearn many concepts that you are familiar with, right? So that's the hard part. And you have to relearn, okay, new ways of thinking using this new computing paradigm, right? You will mirror nature, which is great, right? You're not doing anything new. And actually, we're not inventing anything new here. We're just mimicking nature. And, graphs, they can be, the bridge, between humans and AI, okay, because they have they can talk the same language, okay? Both can understand it in the same way. So moving fast here, okay, you can see the code for this application, and there's actually a more complex application that I have. Okay, it's a tendering workflow. There's 3 different workflows, much more complex than these ones, right? With different levels of vetting. Okay, it's over there. You can actually take a look at it. I'm actually working with the people from Process Tempo to create a little front end for it, right? So that's on my repo. There's a lot of documentation on this. I mean, I've written several articles on this approaches. You can actually, here's my email and my LinkedIn profile. Please send me emails if you have more questions. Okay, I would love to discuss them with you. Yeah, this was a lot of content, okay? I mean, to deliver, this was 10 years of content, okay? Delivered only, 25 slides and 30 minutes. You'll need time to digest this, okay? You probably have a lot of questions, right? And if you don't, you might have to revisit the presentation again. But once you start understanding it, it will click at some point, right? And your mind will change and you start seeing the world from a different lens, right? Once that happens, there's no way back. Okay, you will see how your entire world will change, and you'll open a new way. It's a very exciting way to go, right? So let me see if I can actually answer any questions here. Anyone that no, I don't think. Can you? Yes, I will send a copy of this. Okay, like I said, you can find this presentation on my Medium. Okay, where you can actually do things, and you can feel free to ask me questions. I know this is a lot of content to digest in very few minutes. I still have 7 minutes. Okay, I think I was going too fast. Okay, so great. Alexei, any questions from you? Probably not. So, okay, so since I have some time here, okay, and I'm going to add one more thing here for you guys. This is an interesting thing, okay? So since we have the final of the World Series, okay, last week.
Real quick,
yeah,
you're actually over by about 8 minutes, so
I am.
yeah,
oh,
you're okay.
over.
No, you're totally fine. But if if there's any like other questions you wanted to answer, that'll be great. But otherwise, we'll probably want to wrap so people can move on to the next section.
Okay, no problem.
Thank you so much.
I'll put this online. Okay, thank you very much, guys.
Of course.
Bye-bye.